This week on the BackTable podcast.
There are always people who don't find AI useful. I'm not against them, but what I'm telling you is, as humans, we are aware of the term human error, but we cannot take machine error, which means you bought a calculator. You said 25 times 25, 625, right? You click it 12 times, 13 times it says 624. You say it's garbage, let me throw it away. You understand? That's the problem, and that's why there are high expectations from AI. But what I will tell you is, even if a solution is 70-80% perfect, and it kind of creates not many false positives and false negatives, it is an assistive tool. And again, that's what you want as a radiologist. You don't want a tool to be out of the world. I think people want that, but that is not in the near future gonna happen. You and me know about it. So don't look for perfection in an AI tool. Look for the clinical utility.
Hey everyone, and welcome to the BackTable Innovation Podcast. You can find all previous episodes of our podcast on iTunes, Spotify, and of course on backtable.com. This is our next installment in the BackTable Innovation Show, where you will hear stories from entrepreneurs who are helping to drive healthcare forward through medtech innovation. This is Bryan Hartley as your host this week. I'm a radiologist living in Nashville and co-founder of an early-stage imaging company in the pulmonary space. I'm very excited to introduce our special guest this week, Dr. Amit Gupta. Dr. Gupta is a cardiothoracic radiologist at Case Western. He's been engaged in building and validating novel artificial intelligence-based solutions, primarily on lung cancer diagnosis, prognosis, and treatment response prediction. More recently, he's achieved seamless integration of a novel artificial intelligence algorithm into routine clinical workflow, a one-of-a-kind initiative to improve clinical adoption and implementation of artificial intelligence. So with that, welcome, Amit. Thanks so much for coming on the show.
Thank you, Brian, and thank you for having me today. I'm super excited to talk to you and share my experiences. So, as you already introduced, I'm in Cleveland area, and I'm kind of in a perfect position in cardiothoracic space to test the algorithms. Anything happening in AI generally starts from chest or lungs or plain radiograph.
It does seem that way. Yeah.
So basically, I'm here to share my experiences, and my past training has empowered me to go beyond what a radiologist is initially designed to do, more in the AI space. So I'm happy to talk more about it.
Awesome. Well, great segue. First, why don't you just tell us kind of a little bit about yourself and your practice and your background?
Yeah, so I was born in India, the northern portion of India, in a businessman family. So none of my relatives were doctors. But my father, a physics aficionado, so he inculcated the interest of science and concept of lifelong learning in me. And that kind of propelled me in a direction to study medicine and further radiology. And you can connect the dots here, like connecting link between physics and doctors is radiology. So that's why I became a radiologist. And in further quest of learning, I moved to United States in 2014 and grew here as a physician. And now here I am as a chief of cardiothoracic imaging and trying to learn at the same time as well as implement and teach others about the AI and how radiologists can play a big role in that.
Awesome. So with that, can you tell us a little bit about how you got involved with AI in the first place? Because from what I understand, you're not a coder, programmer. You have a background in engineering in some degree, but it sounds like this just became a passion of yours and really took off.
Exactly. So I always start with a disclaimer, right? So I'm not a PhD or a master's in physics. I'm not a computer scientist, and I know very little about coding. So I'm sure most of the radiologists that are listening to us will relate to me more closely than anyone else in the AI space. So in short, I'm one of you, right? So I still love my day-to-day work, helping the patients, and at the same time trying to answer some questions, which in fancy language is known as research, right? So I'm a clinical researcher trying to answer some questions, and I'm always curious about the new developments around me. And in my quest to do new things, I have volunteered for many endeavors in the past. Like any new modality comes to our hospital, I'm always raising my hand for it, like maybe PET MRI, dual energy CT, image fusion, and also collaborating with the engineers. So as you know, most of the big hospitals in United States are hooked to medical school as well as institution as well, university. So I got that privilege as well to work with biomedical engineers which are kind of one of the most brightest people I have got the privilege to work with. So I started my journey as most of the radiologists do, like helping with annotations, maybe a little bit of clinical input, and then working with the engineers to refine the algorithm.
Specifically, if I could jump in, what was the first thing that you kind of said yes to? It sounds like you've kind of put yourself into uncomfortable situations, meaning like you don't necessarily understand what you're getting into, but you're interested into it, which is it's kind of a rare trait, so to speak. But it's something that allows you to climb a ladder when you don't know where the next rung is, so to speak.
Yeah, no, that's very interesting. So if you really want to dive into history, so I came here as a fellow in neuroradiology in 2014. And at the same time, in first few months, I identified people in biomedical engineering group working on glioblastomas of the brain, predicting the response to therapy and so forth, which I have no clue about at that time what those guys do, but they wanted my input into it. And they said, we are conducting an experiment, man versus machine, and you will be the man in that experiment. I said, that's good. Like, I know the clinical side of the things. I'm a radiologist. I know glioblastoma, how they function. I can annotate things, and that's how the relationship started. And to my surprise, when I visited that place, their room, their meetings, I found out that I'm more valuable than I thought initially. Right? So it's not like they know everything, they have sorted out everything. Their knowledge about glioblastoma was very, very primitive, as expected. Like, I didn't know anything about coding, radiomics, and other fancy stuff happening. But slowly, we met each other. I met with their postdocs, graduate students. They interacted with me. I taught them my part of the story. They taught me some part of their story, how they function, how they use the algorithms in their day-to-day practice. And a strong relationship was kind of in the making already. So next step was I was moving across my fellowships. So I did neuroradiology, nuclear medicine, and I learned everything along the game. So in nuclear medicine, I got interested in PET MRI, fusion hardwares. Then cardiothoracic imaging really excited me. That's where I'm now attending, and I'm now the chief of cardiothoracic division. So with the cardiothoracic space, it was just like opening of the floodgates for the AI. And I was kind of working with the same group in the biomedical engineering for 2-3 years. And at some point in 2020, I would say, I got that realization that let me put everything at one place, what it takes for an AI algorithm to reach to life. Because before that, I never thought of, like most of us, never thought that what it takes as a complete spectrum to create an AI algorithm, right? So I was always working on a part of the puzzle, but I have no knowledge about how the other part of the puzzle works.
So where were you at this point?
I was an assistant professor in radiology in the same hospital.
Oh, wait, Case Western?
Yeah. University Hospitals, Cleveland Medical Center, associated with Case Western Reserve University as well. So I've spent my last 8 years in Cleveland alone. So I have not moved anywhere, which is good in the sense that I was able to make some relationships. And that is required because it's a mutual trust between the engineers and a coordination with the IT team, PACs, and other people. So now we have a very strong team. And definitely, Rome was never built in a day, right? So I started in a very, very simple manner, annotating, talking to engineers, understanding their part. And then there was a time when I started to put all the things on one plate and found out that the radiologist is very, very important part of the game. There's algorithm development phase, somebody's coding something, but there are so many things beyond coding that goes into an AI development process. And most of the steps a radiologist can own.
Were you writing papers on this? Or what was your goal? Let me just start right out. What was your goal with this? Were you just intrigued? You were interested in publishing and kind of furthering your academic career? Kind of tell me why. Let's go with the why.
It was a combination of everything that you mentioned. So I love testing new things. I'm a power user for some softwares. And usually how story starts is a person comes to me and say, I've got something which is the best thing in the town. And you and me both know that there are always limitations. Nothing is perfect in this world. So that's how I refined my skills. And slowly I reach up to a point where rather than just getting intrigued about it, I thought I can take this science forward. And that's where you start publishing, right? So publishing is you add to the existing body of literature. And first of all, you need to understand the science before you take it forward. So it started as a interest kind of a thing, diving it and testing the waters. But soon I found like this is something that really excites me to the next level. And then I started really thinking seriously about it. accumulating a team here, talking to people who are like-minded, and also working with vendors. And I'm not here like to say that vendors are not important. It's just like it's a delicate dance that we perform between vendors, radiologists, informatics, and the users. We always forget the users, and we'll talk more about it. And I think starting as an interest and then gradually moving on to much more beyond the interest is the way to go.
Yeah, snowball effect. So I'm going to back up because I think it's important that you kind of define what AI means in terms of radiology and clinical applications. So maybe you can tell us a little bit about what is AI? Pretend we have no idea. Start with what is AI from like a clinical standpoint? What can it offer? What's the difference between AI, machine learning, deep learning? These are all terms that I hear about and kind of get conflated, but maybe you can just kind of walk us through what those are and, what AI is.
Yeah, no, definitely. I think that's how I started as well. With AI, you are talking about artificial intelligence. But my favorite description is it is assistive intelligence. I think people run away when you call something artificial, whether it's artificial sweetener or artificial intelligence. So I tell my friends that it is assistive intelligence. It's making your life easier. And if it is not, then you should not get it, right? So coming back to what AI is kind of a global term that includes all the approaches that enable computers to perform tasks that require human intelligence. So basically, it's a computer thinking the same way as humans do. And it took some evolution in that. So machine learning, as you mentioned, is another term used. It's a subset of AI, right? So AI is a broad term, whether you are driving a car which is automated or your reports automatically populate with something, right? Or you have a shortcut in that. Everything is AI because somebody is substituting the human intelligence. Then there are different ways to do AI. Machine learning is a commonly used term in our world. It's kind of a subset of AI where the tools or the algorithms are able to learn, interpret, and draw some conclusions from the data. And they function without much instructions from the humans. So that is how machine way of doing the things, and machine learning is the term which is kind of self-explanatory. Talking about deep learning, as the name says, you go deeper into the learning now. And the deeper learning meaning means it works by the layer mechanism. The same way our brain works is by neural networks. That term is also thrown around, right? So artificial neural networks is kind of a multiple layers of processing which extract data in each layer and ultimately gives you the final output. So that is deep learning. And the most common used term in deep learning is convolutional neural networks. So convolutional neural networks is the most popular deep learning method, which is used in image analysis. So these terms are very common, and I think it's a good starting point to know what you're dealing with.
Neural networks, I always see those charts where it says you go from basically step 1 to step 2, pooling or whatever it is, step 3, step 4. Are you basically just getting progressively more filtering, or how does that work when it moves through that process? From step 1, is it like looking at a nodule and saying, what's the size of this? Okay. Or is it just identifying it? I guess you have to choose what you want it to do. Identification, and then talk about the size or look at the size, look at the shape of it, the density of it. And then does it end up just coming to some conclusion at the end of it, or how does that work?
I think it's complex in a sense, but it's very simple in design, depending upon what's the answer you are looking for. It depends upon the question, as you mentioned. If I'm looking for an algorithm which can predict the response to, say, a novel therapy, a targeted therapy, immunotherapy, the first step will be to squeeze out that nodule from the lung CT, which is segmentation kind of a thing. So auto segmentation, which can be refined by humans as well from the training phase. So it segments the nodules, then it looks at the features of the nodules, which may be radiomics or some other subvisual characteristics, and also adding the human features into it, semantic features into it as well. Then it goes through the next layer. So every layer, as you mentioned, refines the decision. And there may be some back and forth between the layers as well. It's not like a one-way direction. Sometimes the data also flows in the back direction. So this is how you design an algorithm, which is very, very laborious process. And that's the real, what you call it, engineering job in there, right? So when you design an algorithm based on the input, so it goes from one layer to the other, and finally it segments the nodule, then it looks at the features, then it combines with the clinical factors, the past growth, the response criteria, and ultimately it tells you, oh, this patient has this % of likelihood of kind of responding to the therapy in hand. So it's a very crude way of explaining it, but I think that's the basic framework of any CNN.
No, that's helpful. And you mentioned the term radiomics. Can you tell us a little bit broadly what does that mean? How do you use that word?
Yeah. So radiomics by definition is kind of looking beyond what humans can see with the naked eye. So as you know that the picture, the radiological images, the CT scans, let's take an example of that, is kind of a collection of pixels which are kind of plastered on your screen. It's kind of a densitometric kind of a image of a patient or anything. So what happens is, as I am trained as an imager, I look at all the visual things, like it's a speculated nodule, it has kind of fat in the nodule, or other features that I'm told that are kind of take you in direction of benignity or malignancy. But I think radiomics looks at much beyond that by magnifying that nodule maybe 100 times and looking at the pixels adjacent to the nodule, how they behave, maybe looking at the vascular patterns adjacent to the nodule, how it affects the tumor microenvironment. And all those features can give you more insights into the tumor biology and the behavior and other features that have been described like Harlick and Colliage and so forth. So there are so many features that different groups have described. So it's like exploring a new territory or a new way of looking at the images, which you and me cannot see by looking at the monitor.
I guess an analogy would be like you discovered a new species of bug that's pretty small. And us looking at it, we're like, wow, look, it has 8 legs and it has this, it has a head, it has antenna. But then actually getting under the microscope and saying, oh, the microscope shows me so much more. There's a hard shell with, how many wings does it have? Those types of things. So it gives you, radiomics kind of gives you a look into things that you couldn't see with the naked eye.
Yeah, I always compare them to the Leeuwenhoek microscope kind of analogy as well. Like before that, we knew that the bugs cause the disease, but nobody has ever seen them. And similarly, when I was in my high school dissecting a cockroach or something, I found out like the cockroach has 13-chambered heart. So which is kind of like a very new information, which I couldn't see from a distance. And you look at a cockroach like anyone else or any other bug. So I'm totally with you on that. So it's just like more information to play with. And again, more information also causes more problems with handling it. And that's where the adoption comes. And there are some other issues associated with it.
Yep. Okay, can you go through the process of kind of developing and implementing an AI algorithm in radiology specifically? Like, what does that look like from starting with defining a problem? What does the radiologist do along that pathway at each step?
I think that is very important for a radiologist to realize, like in that big landscape of algorithms, starting from an idea to working in your hospital, there are very crude 4 or 5 steps involved, and there are sub-steps in there. To know the process from start to finish is the first step, awareness, right? I call it awareness. Once you're aware of the process, then you can slot yourself into different bins. So if we dive into it, as you mentioned, the story starts with defining a clinical problem, right? So what the problem that we are trying to solve, like it may be detecting a lung nodule, like a detection problem, or a classification problem, triaging patients with ICH on your work list, or segmenting a liver tumor, or predicting a response to a novel therapy. So that's the question. And who postulates that question? A clinical person or a radiologist, right? So the first step of involvement is like you have to use your clinical insight that you use 8 to 10 hours a day. So the first step is defining the clinical problem. The number 2 is data set selection, which means like you are trying to obtain a sufficiently large data, which is kind of representative of the population that you're going to use on. Unbiased, that it should have equal distribution of different categories, and that data set will be used to actually teach the algorithm and the same time validate as well. So you train the algorithm on a big data set, big portion of the data set, and then there is a small portion of the data set that you use it to validate and test in the future as well. For example, you have 100 cases. You would love to have 70 to 80 cases in the training set where you are teaching the algorithm about all the variables. And then 10% in the validation, which helps you tweaking the algorithm. And the finally 10% of the cases, or the 10 cases in our example, to actually test it onto the patients that it has never seen to see if it really works. So I think data set selection, again, radiologist will help you getting the data. So you define the problem, you identify the data set, and you know that this data set will get you that question.
I'll add in within identifying the problem. It's similar to like the biodesign process, where the first step we do is identify a clinical need. And what goes into that is a lot. You have to make sure that problem you're looking at or that clinical need is worth it to be solved? Is it something that, if you do solve it, please ask yourself this question beforehand. Is it going to help clinical workflow or the patient or speed or whatever? Is it a problem that comes up enough that it's worth solving? Because you only have so much time in the day or in your career. You need to make the problems that you work on clinically very relevant. And if you solve it on the front end, you're going to help on the back end in some meaningful way.
Exactly. So definition of the clinical problem, you as a radiologist who is working clinically on that patient every day, you will tell that there is an unmet need of an algorithm which will detect pneumothoraces on this big stack of 100 radiographs, for example. I was saying for my friends in engineering side, not to disrespect anyone, I said, you guys are fantastic. You can send the person to Mars, but my patient wants to get treated on planet Earth. So that's another way of telling them that we should not create a solution for something that is not needed, right? So, and that's where the clinical need should be defined by a person who is doing it day in, day out in his or her clinical practice. And you kind of really put that into a right perspective here by like defining the clinical problem means that you should need that tool in the end. You should be using it.
I'm going to go one step further and even say, as you mentioned, pneumothorax. Let's dig in and say, is that really something that I know the outcome you're looking at is we found it sooner because AI found it. It told us to look at these 5 scans. We looked at these 5 scans, small to moderate, large, whatever size, volume pneumothoraces. Have you looked at clinical impact of those things? Not just, hey, we found it quicker. Great job, everybody. Shake hands. Let's move on. But did it change clinical outcome in any way? And how do you kind of work that in? Because I think what I see is that a lot of these problems need to be classified by AI. How much clinical impact does it have? I don't know yet, but I have a feeling that down the road, the goal isn't just to have a pneumothorax thing. It's basically to have something that will just provide like a prelim read for an ER doctor or something like that. But maybe you can jump on that first point and talk about kind of, it's a hard thing to say because, people put a lot of work into these things, but at the same time, what is that clinical impact and, does it matter?
I think that's a fantastic question. And I can tell you from the same example. The pneumothorax algorithm that is working in our hospital, it's working on the PACS. Until last year, I was trying to work on like how to make it implemented, how to educate people, how to get people on board. So now we have moved out of that initial excitement. And the same question, the clinical impact, I've started, or our group is looking into at present, how much time it saves for a radiologist, number one, right? So let's start from the radiology in the center, and then we can go to the bedside as well. So what we created in our hospital was a unique workflow in itself. And that will be presented at RSNA this year. That is a accepted paper. So what we found out was that after hours, after 5 p.m., when there's paucity of the staff that can read the radiographs, really the people that are reading them are the trainees, are radiology residents. So what kind of improvement that happens off hours is a good starting point to see if we can really make a change in the workflow. And based on the study, we could find that many of the patients who were just ordered like a stat with no clinical evidence or suspicion of pneumothorax were timely detected by our residents because we created a workflow of routing the cases that have a suspicious AI kind of alert on the AI. Only those cases were routed to their list rather than all the clutter. So it's not about AI telling me the person is normal. Everyone knows a normal person is a normal. So how we created that workflow to tease out this question of clinical impact to begin with was creating a unique kind of a framework with my amazing PACS team here and routing those cases after 5 p.m., those AI alerts on the PACS to the resident list, despite the fact they were ordered as a routine scan, not a stat exam or something. So now the residents love this so much, like in a sense that whenever they are using this tool, they always keep an eye on the corner of the screen or on the PACS saying that, I couldn't find any pneumothorax, but AI is telling me there is a pneumothorax. What should I do next? They'll look at it again. And many times they find some hidden pneumothoraces. And currently we're working on the clinical actionable versus clinically irrelevant pneumothoraces. So any trace or a small pneumothorax, we trying to tease that as a separate subset from a moderate to large pneumothorax, which can actually harm a patient. So I think we were trying to tease that kind of a question now. And the next step, as you mentioned, is prospectively looking at really at the bedside, what was the impact, how much time was saved in placing that chest tube if anything was done. And another thing that is missing right now in the AI, which is kind of global, I think, AI never looks at a prior examination, which humans do. So we have algorithms that detect the pneumothorax, but the entire MICU floor knows that the patient has pneumothorax since last 6 days, and there's a chest tube in place or something. So I think those are kind of tweaking, continuous kind of a learning thing that is missing right now. And that is where radiologists will come with new kind of a thought processes, and the clinicians will also input in that. And that kind of brings down like a continuous learning kind of a model, which is missing at present moment, and empowering the AI with the same tools that human has. Human looks at the prior, AI only looks at the present. It's an unfair game already. So you cannot beat me just looking at a present radiograph and not comparing with the prior CT that I'm cheating from.
That's what I always say when people say, oh, AI is going to take over radiology. And I say, well, until it knows how to compare a CT to an MRI, a previous MRI, I think we're okay, because prior exams are more important than just about anything else if you have them in determining acuity, severity, and progression. And so that's what I always say. Until you can dig through priors, find the prior lesion, and automatically compare it, that's going to be a tough task, because that's what we do.
Yep. And a very simple example for that in the chest space is, even the bigger guidelines also mention that if I find a nodule which is, say, 1 centimeter in size on the present, and it has been stable 5 years back, no matter what algorithm tells me, I'm not going to say that it is cancer.
Yeah, exactly.
So it's just like that kind of analogy can be used to bring home the message. So yeah, coming back to defining the clinical problem, and I think now we have a decent understanding of that we can define the problem as a radiologist. We have every right to refine that problem for a future iteration of AI algorithm, depending upon how it goes. But I think if the first step goes wrong, you locked your algorithm development in the first step, everything downhill will not go well. And I think that's where the new team of developers are also more considerate about involving the radiologists and clinicians at a very early step. So I talk about like the two algorithms always working in our AI space or in our PAC space. There's a third algorithm that I'm working with the vendor in the background, where I'm involved at a very early stage, which I was not. So it's not like I was always started as an AI local champion or something. So I started like a simple person, annotating, giving my input here and there. Then slowly I realized that there's an opportunity to co-develop the things as well. My ideas create value, and the vendor relationship is improving day by day. And that's how you come to a point where you are at the main table.
That's a great time to ask. And maybe we just keep going on this pathway of, where, the process of developing an AI algorithm, and we kind of stop in between and talk about each one. So how do you work with vendors? I mean, if you got GE, let's say, and they're, they have the PACS system, and they would be the ones who would be putting an algorithm on. Do you just develop your algorithm, with your clinical team and then throw it on the PACS? And what's that like? Do they pay you for this? Let me just ask that question. What are you compensated in besides, I guess, like, hey, we want to learn this from a research perspective. You want to implement this from a commercial perspective. Is it just kind of a quid pro quo from that standpoint, or what?
Yeah, I think the vendor relationship is a must-have for a standalone radiologist. You cannot generate funds and all the resources to do it by yourself to begin. So that's why I really value my vendor partners at all times. So how it started, let's take the same example of pneumothorax algorithm. I was told in, say, later half of 2019 or 2020 that the vendor has a pneumothorax detection algorithm. Can you use it in a way that it is helpful? That was all I was given. The paper was there with a very high AUC, area under the curve. That's how we roughly determine. The algorithm has FDA approval to it. I think FDA approval gives you a right to use it for patient care without many questions asked by the legal, the hospital IT, and the people who are supervising the care. So our FDA approval kind of gets the thing started easily for you. But let me tell you, if somebody approaches you with a FDA approved tool, I think there's the first step in testing that tool rather than just blindly following the FDA approval. And there are multiple papers on that. Don't trust me, read the literature out there. FDA approval means that The due diligence has been done in training it, creating unbiased data set, and so forth. But there's no guarantee of this tool working in your local environment. I'll give you an example. I live in Ohio Valley region. So here there is a big kind of endemic histoplasmosis. So many of our patients have nodules which look very, very angry. But in the end, they turn out to be benign histoplasma capsulatum, which is a fungal infection, very common. So if somebody has trained that algorithm, say in Europe, Asia, or somewhere else, where there are different disease profiles, and I try to play the same algorithm in my environment, it will not work. And that's where we will head ultimately when you empower the radiologist. And I think what we are trying to solve at present moment is to train more and more to make algorithm generalizable to every corner of the world, which according to me is near impossible. I think more work needs to be done in empowering the locally interested people like yourself and myself to take the algorithm and refine it to the area. Maybe Bryan can be a local champion in that natural area, and the smaller hospitals that don't have resources to test it that much, they can take your word for it rather than a person who comes from the other side of the planet, which has done some work on it. Don't take me wrong, but I think empowering the radiologists and the local champions in some areas of, say, United States, all areas, and then you can tweak your things and get it further locked by the FDA. That's a different kind of a regulatory issue. Right now, FDA locks the algorithm and you cannot fiddle with it in the middle of it. You have to get a separate approval for it. So what I'm saying is there's so much of money at stake, IP at stake. So this is not really being open to the radiologist world right now. Nobody's working on really saying that, hey, Bryan, you become the local champion, you own this thing, you refine it to local environment, and you will be a co-developer in that. Maybe there are some initial things going in that space, but ultimately, this is the place where more awareness, more education to the radiologist, and telling them that you really are a big person on the main table. And then they will feel that, okay, I can ask for these things. Right now, most of the radiologists, when they are approached by a vendor or anyone else, they feel that, oh, this is something that is beyond my control. I have no clue what's going on. Let me just annotate the images and get some paid or compensation. And I'm coming to your point of how you should be getting the compensation out of any exercise that you're going with the vendor. I think that's a very valid question. So if a vendor approaches you, how you have to strike a balance between deliverables and what you get in return. So there are two ways if this is your first interaction with the vendor. So there are two ways that you get compensated, either monetary way or in-kind transfer of the software that you're helping them build. And that's how I started. So the pneumothorax and endotracheal tube detection algorithms we got as a part of in-kind transfer. So basically, we were interested in exploring it in a research space. We refined the integration on the packs. We made the algorithm available to everyone, and everyone is using it, which is a big achievement. And in return, we got that algorithm unrestricted use for our system, or for that system in particular, because it's hooked to the machine for the patient care forever. I think that was a fair trade, according to me, to begin with, right? So then it comes to like how much you're putting into it, right? So if you have a workforce, you're working in a hospital setting where you have developers, coders available, then the vendor comes there and you have an idea, you have coders, you need some support from the vendor, then it will be more monetary support because you are co-developing something and ultimately the rights will be shared between the hospital, you. So that's a complicated interplay. But as a radiologist alone, I think there are two ways to go with it, monetary. And that kind of a monetary kind of a model should include people from IT as well, PACs as well, informatics as well, and the local champions, the residents who are working and writing the papers as well. So we make sure that all these things are decided upfront rather than having a disappointment down the lane. So when a vendor comes to you, first of all, determine the merit of the product. You are a clinical person. You can tell that this algorithm detects pleural fluid. Is it useful to me? Will it work in my system? Right? And I want to refine it further or not. First of all, you have to decide internally based on your clinical sense, not on the merit. You can ask some of the literature from the vendor that how it was tested, where it was validated. That may help you refine your decision. But ultimately, once you decide on that, and I can give you an example, many people feel that the algorithm is developed, designed, and given to you. It is sold to the hospital. What can I add to it? Like we got pneumothorax algorithm, totally full-fledged, FDA approved, tested on thousands of patients. What could I have added to that? I think that's missing piece is the clinical implementation. Right now, you have so many algorithms available. At least I know 3 algorithms on top of my head which are FDA approved and can detect pneumothorax. So it's not only about algorithm, it's about, is it vendor neutral solution? Will it work in my setting? And don't take my word for it. You can always ask for a free demo.
Tell me about the free demos. Maybe what is the primary way of testing these things out? I mean, do they have to get access to your packs and or in your images? Is there privacy worry of sending data from your hospital? Let's say it's on a browser, right? Or something like they're not actually installed on your packs at first. And the test is just browser based. You pull up Internet Explorer or something like that and you upload images somehow. Are there safety issues with that?
I think HIPAA is the biggest concern if you're asking a single word answer. But I will tell you there are ways to test the things. So just stepping back a little bit. So there are 2 ways that algorithm can be installed into your system. One is on-premise solution, where the algorithm is shipped to your local server, your local IT, and the data never leaves the hospital. So there are no major HIPAA issues.
Now, who does that? Who would install that? I mean, if it's shipped there, I mean, do you have to get your IT person involved? I'm just thinking of a radiologist who's sitting there, gets called by a vendor. They're like, hey, we've got this new way to find pneumothoraces for you, and you can triage your list and all of that. You should try it out. Well, okay, we're going to ship it to you. Okay, well, what do I do?
That's a great question. So what happens is most of us works on PAC system, right? So there is always some IT support no matter where you are working in the United States. Number one.
Some are better than others, I think.
Some are better than others, right? So IT team or how PACs function is based on DICOM headers and that fine print, all other language. So it's always good to involve your team, the IT and the PACs, if their capability is up to that level. Like they will ship means they will enable us download their software on our local environment, and then you can test it that way. Another solution is on cloud, where you have to open a browser and the images go there and come back, right? So how those demos work, I have tested few of them. Those companies have left some demo AI links. So they created a website and it lets you say upload 10 images of your choice. Suppose I have 10 pneumothoraces in my teaching file. I upload those 10 patients which are unknown to that algorithm. And I upload them and the results are conveyed to me as a demo. And if all those 10 pneumothoraces which were picked by that algorithm, right away I know that this algorithm has been thoroughly tested. So many of the startups or many of the established companies, you can always ask about a demo which can be available. Like I'm working with a company from South Korea right now. So they're ready to install their algorithm on our local server and we can test it for 3 months. And after that, both parties will decide if we want to take the relationship to the next level. And I've never implemented any AI tool without testing. And there may be different ways of testing. One is on-premise, which is difficult because a person will not give you access. Some people are ready to give you demo license. Cloud-based is more common. And then where you need IT and cybersecurity involved in that.
Yeah, where are you sending the images? Every image has DICOM tags with image information in it, including probably patient identifiers. So if you upload a DICOM image to a browser, say those 10 images you're testing, even if you took the information off of the screen, will the image still contain DICOM tags that may have patient information on it?
I think that's very important. As a radiologist, every one of us is aware of data, patient data. HIPAA is a concept that is not a new concept. So it's not a new thing that I'm learning that I don't have to share patient information in the corridors or post on social media.
No, but you may not know that images carry their own DICOM identifiers, which a lot of radiologists probably don't know.
No, that's a fair thing. And that's where I will say that there are some de-identification tools available in your packs. There are some free available online as well, like DICOM Cleaner and so forth. And there are some from RSNA. It's like we are in a world 2022, not in 2002 or 1992. We have so many resources to remove those identifiers. And your IT team or your local team can spot check the cases. That if this solution is working or not, do your due diligence and then push those cases. And many times, most of the PACS systems have inbuilt thing. The problem arises when you want them to de-identify 100,000 images. But for the demo purposes, you're asking 10 images and tell them the worth of this software. And then they will give you this 10 images, or you can get them some other way, depending on how much your relationship with the IT and the PACS team as well, right? So if you are at a state where you don't know anything about de-identification and the people you're talking to have no clue about de-identification, right? Then you can introduce the concept of free DICOM removals. And the IT people knows about DICOM headers, right? That's how the PACS work. How all the information is stacked on your PACS is it reads those DICOM information. And there's a document by Safe Harbor Standards that tells you that you have to remove 18 or so things out of the patient DICOM headers, which is kind of considered a protected information. That's where the due diligence come in. And usually the cybersecurity and IT people have more than preliminary understanding of that. We are privileged that we also have a parallel research PACS available. So there's a patient production PACS that we work on, and there are research PACS where we are privileged to have that. So we use that research PACS in a fashion of a testing kind of a environment. But ultimately, testing can be done on cloud environments by some sample images at no cost to you. And please don't use any algorithm just like taking a word from somebody from, say I'm in Ohio, somebody from California says like, oh, this algorithm is awesome. You need to have it. I will trust that I need to have it, but please have a demo of it or as a prelim due diligence from your side before actually paying for it and kind of getting into your system. That's the bare minimum.
Okay. No, I think that's a really good point. So can you trust all of these companies, I guess, with the data that you're testing this out on? Because I'm thinking about the risk benefit, and if an AI company comes to me, because there are several of them out there that are all, they're always contacting and saying, "Hey, are you interested in this type of algorithm?" And it just feels like there's a lot of work to do to even test it out for marginal benefit. So, do you think it's worth the risk? Do you think everyday radiologists should be interfacing with vendors and saying, hey, let's put this on our system and try it out? What does your perfect world look like in terms of interaction of everyday radiologists with AI?
I think you have to start from somewhere, right? And the first step is, if you have never heard about the word AI, which I'm exaggerating, everyone knows AI, you Google AI in radiology. And the top 3 hits, I can tell you where the radiology AI is. It's not like we are rushing in that direction, like tomorrow, Bryan, you are losing your job. Day after tomorrow, I am losing mine. We are not in that stage, right? So first is you educate yourself where we are. Talking about vendors in specific, I think there is always a discussion phase. And that's what I'm saying. If you have a FDA approved technology and a vendor reaching to you with, say, FDA approval, they say, we have a FDA approved product. Then you have a certification in hand to use it for patient care. And there is a legal safety with you, right? Because somebody, a big authority, approved that for patient care. I'm not saying so you will not be legally wrong in using that algorithm. What I'm saying is the utility of that algorithm for the patient care should be tested. And if it is a new startup, then they will be ready, more flexible to give you solution as per your comfort. Like my institution is not comfortable vendor pulling the images, but a person from our side pushing the images to them. You understand what I'm saying? So it's a local comfort, and that bargaining game goes based on where you are and where that company stands. If there's a big company which has established track record, FDA approval on it, so there's no harm in getting it to the clinical environment. And that's how people test the things. And the only thing is it worth paying for? Then the question changes to. And that's where you radiologist will test it on sample patients. And they are very flexible on how many patients you want to test on, usually, because they have to sell their product to you. I think that is the best way, try and buy rather than hear and buy, right? So I think that's a better strategy to go with the AI in the present world.
So you have been using several solutions correct? I assume you've been using the pneumothorax and the endotracheal tube identification. Well, let me just ask, big picture, do you think they're worth it?
Yes, they are worth it. Number one, and I will not say without a grain of salt. The thing is, right now, these solutions are expensive. Let's face it.
How much are they? Do you know, ballpark?
Tens of thousands for some of them.
Tens of thousands per year?
Some of them, it depends on the model, right? So some of them comes with the machine itself. So there are solutions which are housed on the scanner itself. So you bought the solution with the scanner forever. And some are cloud-based solutions where you pay a contractual fee. Like there are algorithms that pay per charge. I mean, you may have heard about HeartFlow, CTFFR technology for coronary artery disease. It's super expensive, but it's worth it, and it has been proven with multiple trials, and a lot of institutions use it. And the newer guidelines also incorporate this technology because it's net worth dollars saved for the institution as well.
Yeah, that's a very clear economic value proposition when you consider, money saved or reimbursement. I mean, positive reimbursement. FFR, I think, reimburses a decent amount to do that. It didn't used to be that way. But now let's kind of switch to kind of bread and butter, pneumothorax or ET tube, those things. Because I mean, that's what a practicing radiologist is going to look at and say, what is the ROI in my practice, whether it's to patients or my practice financially, for like doing the work of talking with the vendor, figuring out the privacy, beta testing it, and then deciding on whether you're going to use it, and then implementing it and taking the time to do it and evaluate it. So that's definitely an investment. And I guess, what would you say to that?
No, definitely it's an investment always. And I was driven by my excitement to test new things. And many times, historically, we have been testing things without any fruits associated with it. I've written so many papers on dual energy CT. Nobody paid me anything for that.
Now there's lots of dual energy. I mean, we have it at Vanderbilt, and it's being used a lot.
No, that's what I'm saying. So when in 2019, the vendor asked me to do a webcast, which was telecasted worldwide on dual energy. And I talked about clinical adoption of dual energy. I said, you can easily impress anyone with those 10 kV increments and so forth, but that will not bring a radiologist on board. And again, coming back to your question, like if I have to go in the market to buy an algorithm, right? So first of all, I will look at the literature. All the three examples of, say, pneumothorax detection is of interest to me. I will look at 3 players in the market who are FDA approved. Then I know how to read the literature. That's how I became a doctor, right? So I read the literature, then I say like, oh, I narrow on these 2. The third one does not seem exciting to me. It was trained in Australia, right? So I want to have
their pneumos are different over there in the Aussie land.
No, maybe the machineries and other factors, right? So patient factors. I don't know, because I don't know what are the hidden factors affecting. It's a black box to me.
Yeah, right.
Right? To begin with, I try to play with my intellect and what I have learned in the past few years. And then you say like, okay, this is a tool here. This is FDA approved, right? And if I'm in so much of initial stage, I can always ask vendor, can you connect me to the other bigger sites that have been using it for last 5 years? And suppose you have to buy that pneumothorax algorithm and you and me are connected. You say, hey, Amit, what's your take on this algorithm, right? So my answer to that is, it's not %. And none of the AI solution is %. You know something? There are always people who don't find AI useful. I'm not against them, but what I'm telling you is, as humans, we are aware of the term human error, but we cannot take machine error, which means you bought a calculator. You said 25 times 25, 625, right? You click it 12 times, 13 times it says 624. You say it's garbage, let me throw it away. You understand? That's the problem, and that's why there are high expectations from AI. But what I will tell you is, even if a solution is 70-80% perfect, and it kind of creates not many false positives and false negatives, it is an assistive tool. And again, that's what you want as a radiologist. You don't want a tool to be out of the world. I think people want that, but that is not in the near future going to happen. You and me know about it. So don't look for perfection in an AI tool. Look for the clinical utility. Many times we forget what we are good at as radiologists. We can easily tell that, oh, if it finds like all the clinically actionable pneumothoraces, which are large, which may require a chest tube placement, and if it misses the trace or small pneumothorax, I can live with it. Rather than saying, oh, the numbers of sensitivity fall from 90 to 75. But you never took into account the clinical impact of it. So I think I will not endorse anyone. I'm not here to sell an algorithm. I don't have a major stake in anything. I am just like one of you guys. I test things. I put my thinking cap on. I know what's the merit of the technology, and I test it out in a demo space. I include the other experts in my field. There are people who know chest radiographs by their 20, 30 years of experience. I was in high school at that time. I cannot match it. So bring your team in. You're working in a hospital setting. Make a joint decision. Your chair, your IT team, your PACS team, and then combining everything together, then you can determine that's the price of this algorithm. There's no single answer to that. Oh, it is fair to pay for it.
No, I agree, but I think to be honest, one thing that I keep hearing, and this is probably a good place to put a bow on it, but will AI replace radiologists? And I've heard you and many other people say, it's like, no, it won't replace radiologists, but it may replace radiologists who don't use AI, because it is going to play such a big role. So when you think of what's the return on investment, maybe right now, yeah, it's not going to speed you up, 30%, 40%. It's not going to increase your reimbursement by 15%. But getting to know this now will pay dividends down the road. When those types of solutions do come out, you'll be ready to jump all over them and modify your practice accordingly, because you've been kind of part of the process from the beginning.
Exactly. You don't want to land up in a situation where one Monday you get a news like, oh, this is happening to you. We don't like things happening to us. We have an opportunity. We all are in infancy. Take my word for it. Some people are a tad bit ahead or some are behind. There's a lot to be explored here. So we are at a right time in the history as radiologists to press the pedal from our end. Otherwise, there is a big kind of a chance that you lag behind in that evolution. And definitely, as you mentioned, it's an investment for the future. And I tell you an example from my side. I started working with vendors, right? And it's kind of a very open statement here. So I got some internal grant, which is not more, 10, 15 grants or something. What I did with that grant, or I'm planning to do right now, is buy some AI equipment for my system. And trust me, in 2022, it's not expensive at all. I am trying to empower my program so that my radiology residents sit on that computer, that annotation tablet. We always talk about annotation. How to do that? Our radiology residents will be facing this more than ever. There's a processing GPU. What is GPU? Graphic processing unit, right? So once you have the toys to play with, I always say, I'm buying a new PlayStation 5. So don't ask me question which game I'm going to play with it. Let me buy it first.
Yeah, that's a good point. It's very interesting that you're buying equipment so that your residents can basically train how to be a part of an AI, how to interact with it, give feedback, use it, evaluate it, all of it.
And to take it to the next level, I'm talking to the same engineering group that I worked with, and they are ready to send their postdocs to my reading room or the room next to my reading room where this equipment is. And they are ready to work with my residents, their postdocs, who are engineers, coders, and so forth. So there's a good exchange of information happening. So it's best of both worlds. And that's the initiative. It is very fresh right now. It is happening that I put in the order for the equipment right now. It will be here in next month. I've talked to the BME, biomedical engineering collaborator. He's super excited about it. He's ready to send his postdoc. So there's no IP battle going on when you're developing something new. And what it will empower us down the lane, I can tell you right now. Many times I'm convincing the vendor that this is a good clinical question and nobody's ready to listen to me. They say like, oh, I don't believe in that. So it's high time that I start developing my infrastructure. I have engineering people who are ready to collaborate with me. I know the puzzle. These are the 5 pieces in algorithm development. I cannot code, but I know people who can. So people who are ready to collaborate with me will be brought under the same umbrella, and we'll develop something together rather than a third person comes to me and saying that your clinical idea is not good enough. I think it's a step-by-step procedure.
Gives you kind of the power back a little bit there, but I love the idea of training residents to do this because I don't know many programs that are doing that. An analogy would be using a surgical robot. There are probably lots of surgeons who didn't use robots back in the day. They didn't adopt it. But then you probably find that residents and fellows want to go to the program where they can learn how to use Da Vinci. Whether those outcomes are proven or not, that's a whole separate argument. But they want to know how to do it. And that's the thing about residents and fellows is they do want the cutting edge a lot of times. And if your program is at least teaching residents, hey, here's what AI is. Here's how you can evaluate it. Here is an example, couple programs. You should use it and play with it when you're on call. That way, when you get out and a vendor comes to you, you know how to communicate with them. You know what that process involves to test out on a browser. Is it going to be locally derived? So, I mean, you're making me at least think about training, like, hey, don't get behind the 8 ball here.
Yeah, it should not be like you start taking Python classes today.
Yeah.
It's very
No.
primitive know-how.
Yeah.
And to be frank with you, I'm taking some Python classes now. So if you are calling me on a podcast and thinking I'm way ahead in the game, I'm not. I'm still learning. We all are in the same timeline. I'm telling you my story very openly without any coding experience, but it's always good to know all the pieces in the puzzle. Educate yourself every day. There are free resources available right now to educate radiologists. ACR, AI Lab. They don't pay me. I'm just quoting the things that are kind of low-hanging fruits. Kaggle, you may not have heard it, but you must have heard about RSNA AI competition that is held on Kaggle. And when you go to Kaggle.ai, they have some courses free for you to learn anything. So what I'm saying is those are the things of the past that nobody's there to teach you. You cannot know what AI means, what a Python algorithm looks like, what a ResNet is, and what are the architectures used for training something. Once you start reading it, I think that is must have when you sit on a table with a vendor as well. When you sit with a vendor, and they will put their money on you only then if you have any experience with anything. You say, oh, I have seen 3 algorithms working in my practice. Now let's talk about it. And then they really say like, oh, we want to collaborate with you. Your conditions are met. Your IT people will be compensated. You will be compensated. Your residents writing the papers for us will be compensated. You'll get some license on the software. You get some kind of discount on the software if you ask me. So I think it's all about empowering radiologists to bring more at a table rather than I'm just saying tomorrow is radiologist era. I think being a cardiothoracic person, I don't want to lose that part of the puzzle that I should have owned. And now I'm trying to really own those 4 or 5 pieces of a puzzle. It's not a big puzzle. Defining the clinical problem is mine. Data selection is mine. Data preparation, my people can do that. Ground truthing, I can do that. Ground truth is I annotate things, right? So that is ground truthing.
You do know how to do that, yeah.
and the algorithm development, I'm trying to find people who can write codes for me, right? Or the vendor can fill in that space. Clinical implementation and monitoring, that's where I made my name. So I was given an FDA-approved algorithm and people were saying, what are you doing? You're spending your time in a wrong direction. This is done deal. But I've seen softwares nobody in the system use. And now I have 2 examples where everyone in the system uses that. And that's where I added the value after everything has been done according to traditional algorithm development. That I annotated, he trained it, FDA approval done. There's nothing for you, buddy. So I think we have to change that mindset. And the only way we can do that is try to educate yourself, and it will not take long. Trust me. It's just an inertia that is stopping you rather than anything else, because you were never taught about that in your curriculum as being a radiologist. I was never taught about it. But really, if I really want to dive it today, maybe 10 years into my career or 20 years into my career or 25 years, nobody's stopping you. And trust me, there are vendors who are looking for clinical partners left, right, and center. And you need not to be the data scientist of the century to collaborate. You need to be only a radiologist who's ready to think how you can use these tools with a little know-how that is available online for free.
And with that, what are some of the what top 2 tools that you would go to if you're a radiologist and you want to just learn some of the basics of how it works?
I think start with Googling AI in radiology. There are papers written. Go with the citations. You'll find one paper with hundreds of citations written in 2017, 18, and so forth. But every big journal has that kind of a thing, right? So that is a starting point. You read an overview of what is AI. Then you go to the next level. All the things that I'm telling you, the points, it's not that I created. I learned it from somewhere, like ACR AI Lab is one there. Go to their Learn folder and you'll see that how they teach you. Go to Kaggle. They have courses, learning courses. You will know what coders do. At least you will know what coders, how they type in Python. Python is no longer a snake for you. It's a language, right? That's how I started. RSNA has a separate journal in itself. Radiology Artificial Intelligence. And being a resident, you have the free membership of RSNA. And most of us attendings are members of RSNA. Please read their articles. They will slowly start making sense to you. There are different courses. Coursera has some courses, right? So there are so many names. I don't want to say like this is better or this is worse, but once you start through it, you'll find out what excites you most, which is easy to do. And there are some paid as well. RSNA AI certificate course. It has some charge associated with it, but it drives you through that basics of AI. So depending upon what you can afford, where you are in that learning process, please, there are so many resources available. Start with the Google and sky is the limit.
I love it. I think that's a great place to stop and I'll go through a summary and you can throw in any comments as I go through or any side notes to this. So first off, you raised your hand when it came to new ventures in your department. You said yes to some of these things that might be uncomfortable at the beginning because you don't know much about it. For example, when the computer science teams came to you and said, hey, we want to evaluate this GBM treatment response. And you said yes, and then things snowballed, which I think is an awesome thing and a great point. How amazing things can happen from just saying yes. Also, as physicians, we have more value in AI than we think. Don't underestimate your contribution to the process of clinical AI solution development. And that's probably one of the big keys to everything we talked about today. You're such a key player as a radiologist. For those listening out there that are radiologists, it's very important that you don't undervalue yourself. Make relationships with your engineers and your IT team. It's important to get started, that you make friends and you know who they are so that you can work on clinical problems. And maybe we can finish this out. The first step for AI is defining the clinical problem. Make sure that clinical problem is worth solving if you're going to work on it. And make sure you select the right clinical data set. Quickly, what were the other 2 or 3 steps?
Yeah, so defining the problem, data set selection, making that data palatable to the algorithm. The fancy word for that is data set preparation.
Modify it, yep.
Yeah, and then you annotate it. Then the algorithm development. That is the real, we say, computing involved in that. And finally, you take it into your clinical setup and implement the way that it is helping your system. It's very simple process.
Yeah. Okay. And radiologists play a big role in just about all of those. Maybe not the actual development of the algorithm, but everything else is critical. And that's probably 90% of the whole process. It should involve a radiologist. If a vendor comes to you, you can test the tool. In fact, you should test the tool. First of all, you need to decide whether it's a clinical problem worth solving, if it's going to make your life easier. That's why you call it assistive intelligence, not just artificial intelligence. If it doesn't make your life easier, don't get it. And also don't just take their word for it. You know, the FDA doesn't really look at different areas of the country or world. They don't know the prevalence of histo. It may not be as high in some places of the country than it is where you are. So you need to make sure that you use it locally to make sure it has the same relevance and doesn't have a bias built in. HIPAA, with testing, HIPAA is probably the biggest concern. You can download it to your local environment and use it locally. That's probably the safest way of doing it. You need your PACS team help with that. But you can also use a browser and upload 10 images to a browser version of this and see how well it works. And that way you can decide for yourself if it's worth it. Is that ROI there? One important point there is, it is important just to get started in AI. I think coming around to it, some of these problems that they're solving right now may not seem, oh, great, everybody can find an ET tube or a pneumo or whatever, what's the real clinical impact? What it means is being involved in AI and its use early on so we can help A, shape it, but B, so you're not left behind. I think as a radiologist or an imager and in many other fields as well, there's going to be impact from AI. And the earlier you get going with it, the better off you're going to be, the better off you're going to be able to adapt later on. And, it'll pay dividends. Whether you see it now, it's going to play a big part in just about everyone's field, probably. Finally, educate yourself on AI. Just Google AI in radiology. The ACR has the AI lab. Go to the Learn folder there. And then there's an RSNA journal if you have access to that, and check it out and just start diving in. Answer a couple questions that you have and learn about it. And then you'll be able to have a much more thoughtful discussion probably with any vendor that comes to you so that you're well equipped and well armed to make the right decision for you and your practice. What'd I miss?
I think that's an elegant description. I'll add one piece that we didn't dive into fully is data sharing with a vendor. So data sharing with a vendor is a good thing, but you should understand in the present world, data is a commodity, right? You may be hearing bigger companies collaborating with or bigger hospitals collaborating with Facebook for multi-million-dollar deals. I don't want you to sell all your data like that. But how we are doing right now after the initial learning process, we always hook the data legally to a project. For example, somebody comes to you that we can develop an algorithm which can calculate the calcium score on a non-contrast CT scan. Simple. We want some CT scans from your system. Then we'll say like, okay, let's frame a contract. We'll give you 500 examinations for this project. It's not like you are using that CT scan in future for measuring the aortic diameters or something without our approval. So try to be savvy on that front, be collaborative. And I think everyone will listen to you when you say that, oh, what is the project here? Just selling the data, anyone can sell it. Where the radiologist is there? Is there any project? Is there a paper that I can be part of? I'm happy to put my input into it. Maybe you're collaborating with a platform that is hooking you to, say, Stanford, big place, or MGH, or big places in there. That may be a segue into big boys club. You are trying to learn. So bottom line is learn and teach, right? Learn yourself and teach the future generations. Data is yours. Your intellect is yours. Play wisely with all the constraints of HIPAA and others. And collaborate with vendors. I'm not saying no to that, but understand that you are worth it. You need not to be a scientist, PhD, coder, or some fancy person to be a champion in AI. You just have to find your space looking at your clinical problems, and I cannot teach you that. That's where you have to play that game. Otherwise, if that idea I give you, then you become successful. I will not. I'm just joking there. But what I'm saying is you are more savvy than that, and you can easily find the solutions to your own problems. That's how we do it every day. There are some cases that I have no clue about every day. Then I read the literature, I do my due diligence, and then issue a report. Similarly, this is an area which is kind of a case that you have never seen in your life. Deal it that way.
Awesome. Thank you so much for sharing your time and your expertise. I think that was a fantastic discussion, and thank you so much for coming on the show.
No, thank you so much, Bryan. It's a great pleasure talking to you, and we'll stay in touch.
Thank you so much for listening. If you haven't already, make sure to subscribe, rate the podcast 5 stars, and share with a friend. If you have any questions or comments, DM us at BackTable Innovation on Instagram, LinkedIn, or Twitter. BackTable Innovation is produced and hosted by Bryan Hartley,
Aaron Fritz,
and Eric Amaker.
Our audio team lead is Kieran Gannon, with support from
Caleb Hodson,
Josh McWhirter,
and Ness Smith-Savadoff.
Design and digital marketing led by Brian Schmitz, with support from
Ann Dang.
Social media and PR by Chi Dang.
And Dana Parker.
Thanks again for listening.
See you again next week.